एबे एसी एसी चलछि एसी तले एटा खोला रखो एटा हां माने एटा खोला रखले कोन कि वेंटिलेशन हले एते उडा पिल अछ ना हेला ना कीर्ति मैडम कैन वी स्टार्ट okay so my actually due to some interruption uh, we have some gaps okay so stream energy is also very important in our fluid dynamic aspect of this river morphology canal morphology means stream has the energy to carry out the discharge and to carry out the sediments okay that energy you have to calculate and that is sometimes it is more when it is more actually it will take the discharge properly and there is no problem to the rivers when there is actually less energy to the stream then you see the deposition will be there so that thing is also very important sediment load capacity because whatever the sediment is coming the capacity should have actually the appropriate capacity so that sediment will move and okay these things actually we'll discuss also actually I will tell actually one of the experiments has been performed by my latest PhD students I will tell that engineer Satish Kumar I will tell about him actually and the work also we'll discuss gradually finally these things we are worried concept of graded stream what is that means is a equilibrium a stream in equilibrium is called a graded stream if it has the you see a graded stream is one which has over a period of time the slow is adjusted to provide the available discharge and with prevailing channel characteristics so that the transportation and then all the drainage will have the very easy way of flowing the slow discharge channel character sediment load all these things actually relate to the concept of graded stream means इतना slope होना चाहिए जो कि all the things will very factors influencing the river morphology I have already told but you see in the broad sense you can tell three factors influencing the river morphology external is a natural or anthropogenic factors and the sediment dynamics and third is vegetation actually I have already discussed on that finally human impacts on river morphology urbanizations industrial these three actually impacts actually that human is responsible for that and implication of river morphology on ecosystems so implication is habitat diversity riparian zones and ecology interactions okay actually I am very quick to tell about actually that about regarding the experimentations how the model all the previous things what I told actually you can get in very really in the books and nets and many YouTubes also but it is very important that how you can develop some models and you can understand some models which are helpful for research and also for designing and okay for engineers also it is helpful you see actually main things we worry for both our researchers and engineers floods flood को how we can manage. And floods are mainly due to the 4 reasons. Remember, okay, mainly 4 reasons. First is heavy precipitations with poor drainage. Second is insufficient floodways, wrong or inaccurate estimation of channel capacity. Fourth is inadequate reservoir capacity. 4 चीज के लिए होता है फ्लड. First is natural, we cannot stop it. Precipitation. Precipitation generally it is a very natural, we cannot stop it, or very less role हमारा है to control it. But as a researcher or a designer, actually we should responsible actually for wrong or inaccurate estimation of channel capacity. Mainly we do research or do modeling to correct this third is very important. उसको माप नहीं किया जा पाएगा. If you have the wrong estimation or inaccurate estimation, तुम जो मॉडल यूज कर रहा है वो accurate नहीं है or wrongly you are calculating. That things actually on that actually generally research होता है and design का सब change होता है. Other things actually also it is sometimes natural, sometimes man-made. Okay, you see, suppose insufficient floodways, because many times we are responsible that drainage fix नहीं करते हैं. Even in the cities, you see, due to flash floods, कितना flood माने हो जाता है, माना problem of flood occurs, isn't it? In Bhubaneswar, you see in the Chennai, many places in abroad also, because we are not keeping proper drainage system, flood ways. Okay, so I will tell regarding this the wrong or inaccurate estimation of channel capacity from good figures. Okay, I will show to make you interest. You see, this is a river and flood plain, and you see some foreign rivers actually, and that flood has occurred. Heavy flooding in the river Thames. In Indian rivers, we know we are always seeing that river Manadi and other things, but actually I have collected some okay out of our country ka river ka. France, unka dekho, okay, and these are the flooded. You know, due to flood, हमारा कितना not only the life, properties, economically बहुत परिप्रम हो जाता है. All of you know it. Okay, you see, in generally you see in a channel we investigate in this. I have divided actually six categories of this channels for investigation. Straight and maintenance channel, compound channels with vegetations, non-prismatic compound channels, unsteady channels, and channel with sediments. So these 6 types of channels. Actually, I am tempted to tell all these 6 types of channels in NIT Raukala. We are doing research. In our country also, actually, very nicely we are doing research on this. And mainly, our research is on prediction of discharge, prediction of shear stress. Okay, all the things for this, all types of channels. All this actually I have already described. River morphology, this channel geometry is changing, and this is happening. And finally, our need is to how to get the accurate estimation of flow. Straight and maintain channels, we have the collaboration with eco universities, I have told, and we have done some research work in NIT Raukala last 20 20 years हो गया, because I did my PhD also in an as a faculty actually. I had got selection in the Commonwealth also. I was in that. I missed that because as a faculty हमारा था कि we have to do PhD in our own institute. That's why I started doing my PhD there. Okay. Anyhow, that was a great opportunity for me to develop actually. Now our laboratory is the actually laboratory. I have already told you, it is one of the best laboratory in the not only the country and the world. मुझे जो लगता है कि even it is a comparable IIT Kharagpur or IIT Roorkee. मुझे जो पता है कि हाइड्रोलिस में already everybody knows NIT Rourkela, IIT Kharagpur and IIT Roorkee और कुछ होता है पता नहीं, but what I know we are doing it. But in NIT Rourkela we are mainly focusing on this open channel hydraulics, all these 6. And state maintaining channel में हम लोग UK University of Loughborough, Birmingham, Nottingham, Leeds सबका साथ कोलैबोरेशन है. Our Indian project, Eco India project हमारा था actually, and the professor of there, they were also collaborators. उनका जो project था, I was also with them. And many of my students actually, PhD students, master students also, had gone actually UK for this, helping this. Then compound channels, river with flood plain. Okay, and that is a uniqueness actually because of momentum transfer. Again, there is a loss of energy that you cannot see or visualize in simple Manning's formula or Chasis-Darcy's. Okay, that things also we have already contributed. More than 100 SCI and Scopus actually, Scopus and Web of Science and actually reputed journal paper. Through me actually it has already been published. More than 100, more than 200 or 250 actually. Sorry, I forgot actually. In conference proceedings are there, all related to this. Okay. Compound channels and compound vegetations. It was a UK project, and my student, actually PhD student, Saini Sikta, she has gone there actually. Madam Lakshmipriya, I think you know now, Lakshmi, she has gone. And non-prismatic compound channel, another, it is a Eco India project also. We are awarded, both British Council and India UGC, they have given. I was the main PI. उधर में हमारा 2-3 PhD students, हमारा NIT पटना का जो faculty भवानी, he is also involved, and another professor Bandita, non-prismatic compound channel. Now recently actually I was a visiting professor to Lyon, France. Again collaboration with the France. I was a visiting professor, and with family I had gone there instead. And that is related to unsteady flow. Unsteady flow का actually नहीं है, आज तक कोई अच्छा मॉडल नहीं है, इसीलिए to face the challenges. In India we are doing research now. I had got a DST project recently around 70 lakhs to do only research on that. Like हमारा student, those students है, one is Suchit, another is our Sarjati Saab. He is completing now. On study में they are working. One is completed, another is working. Our Gyanaranjan Khuntia actually, he has got in a Ramon Choppa fellowship in France. He had gone France actually 6 months. My student stayed in France. So on study हम लोग काम कर रहे हैं because बहुत complex है सब research in that channel. Okay. Finally, channel sediments recently one of my student PhD completed. उनका नाम है Satish Kumar, Dr. Satish Kumar now. His background I am telling you. He is a IIT Kanpur BTech. IIT Kanpur BTech. Okay, and he is actually the engineering service one of the topper. And GATE का भी topper थे. And actually, luckily, actually, I got him as an engineer in our Rourkela. He was there, posted there. And sir, actually, one thing, Jyoti sir bhi hai, he is very famous and popular to us, and he's also very much, you must be knowing actually after my presentations. And he was also much involved with us actually. anyhow. So that Satish Kumar, River Koyna sir, actually River Koyna, we have done some field survey. I'll show some slides. Okay. So today I'll just extend some half an hour on that. Then I'll stop because next presentation will be there. Very quickly I have to tell, you see, meandering channels. I already told many influencing parameters actually, aspect ratio, because finally it should be applicable to the field. Okay, whatever the that equations or models to develop, it should be applicable to the field. So non-dimensional parameters you have to take for our modeling so that you can apply to the field. Okay. Aspect ratio, Froude's number, slope, equivalent roughness, all these things actually are non-dimensional parameters. And in a DST project, Madam Lakshmipriya was also involved. We have the 5 types of sinus channels we have made, and we have modeled actually. That is again through DST project. It has been fabricated in NIT Rourkela. We have done actually. These are some clips of this channels. Then compound channels, and our Sipra Rani Pradhan, she is a faculty now in OUTR. She has done in how actually due to roughness changes how the compounds are behaving. She has done it. So different series of this is again another DST projects. So these are the facility actually in NIT Rourkela. You see, we are doing the model studies. Jyoti sir actually many times we have also collaboration with him actually, and with the water resources departments. You see, it is we have actually complete recirculatory system of water supply system there. We have control manner because we know the discharge, we know the parameters, we develop the models, and we see actually how accurately it's predicting. Then we apply to the other experimental channels and rivers. Okay, so different ranges actually. Very quickly, I have to tell them still. I think another 30-40 slides are that. This is the eco project actually in that. This is Lobro University. Our one of the students regarding vegetation actually. These are the compound channel of vegetation रख दिए थे. Due to vegetation, how our everything is variables, flow variables changing in a compound channels that has been studied there. These are unsteady channels in France. I was also a partner with them. Again, no, there is a non-dimensional parameter. In the hydrograph, SP means peak, SP means base flow. Okay, and this TR is the time of this rising and falling का जो time होता है. And UC is the average velocity. And that actually this is decided already by the investigators. This is called lambda, is unsteady parameter. This is the France laboratory actually I had what? My student also what? And उनका जो student को भी हम guiding we have guided actually there. PhD students. And here in NIT Rourkela also we have done some experiments on this non-prismatic, non-informed channel. Okay, so I am very tempted to tell, but due to time constraint, actually I have to go very quickly. Many non-dimensional parameters. Actually, through that we decide many publications actually in the ASC American Society Civil Engineers वो बहुत recognize है. वही basis से software बनता है. That software we apply in our fields through our engineers and IIT, NIT and VSSUT like that reputed university में होता है. Okay, so पेपर जो पब्लिश होता है माने that is has an impact actually. Software it depends on that. वो लेता है that you have to know, and mainly that ASC journal papers and the journal of hydraulic engineering भी है और एक. Please I advise you that in our water resources you try to publish in that journals. Some LC papers, Elsevier journals also good. So these are regarding the composite roughness actually. Okay, sorry. And now I will tell about very quickly within a year about my last student, Satish Kumar. he's an engineering service, that he's a chief engineer actually. But why I'm pressing him, though he's a senior professor like he's very much tempted like our engineer Jyoti sir. Railway sir, railway. Yeah. And now he got the PhD sir. He's a IIT Kanpur BTech, and I'm telling you, sir, I mean that get का भी बहुत अच्छा, means maybe one of the topper like that from zones I understood forgot, and engineer service का भी बहुत अच्छा rank पड़ा. Anyhow, and he has published 2 papers, ASC and our water resource management. और 2 publication भी है. इतना tempted है. He just 4-5 years junior to me. Okay. तो उनका thesis का glimpse I am showing you very quickly. Thesis का बहुत सारी ये content है. I will share that PDF, but not possible to tell now within this very short of time, very less time. Okay. So flow resistance, bed loads, all the things you know. I assume that you know, and some figures actually, and the natural labors ka how is seen that. Okay, these are the figures actually. Bed load movement, steep mountain rivers through Google images actually we have collected from you see satellite images showing normal river and sediment rivers. वो सब तो पता होगा actually, हैं? Okay, very quick live to see. Actually इनका objective में वो था कि friction factor of sediment bed. How to have a model, good model. Friction factor of a with a river with bed load, and that is the friction factor. Then to have the bed load, transport rate, and seals parameter, all the things actually he has developed. We have developed through his contribution. So in our NIT Raukala actually, another setup is with us. वो sediment को पूरा recirculate करता है. Sipra has done some part. Then after that, our Satish Kumar, I think my 13 PhD student. Actually, हमारा department में तो मेरा highest PhD students actually. It has been through me actually, because I love research and academic. Anyhow, okay, so 13 or 14 I forgot actually, PhD student. And these are the recirculation system of पानी का तो था, sediment का recirculation system also we have fabricated there, and it has been again from changes we have made. Sediment trap management, movable bridge, all these things actually there, because that supports making readings. Okay, all these things, facilities. So actually these are the, you see, 3 series of experiment. It has been conducted through our Dr. Satish Kumar. Series 1, Series 2, Series 3. Series 1, 12 sets, discharges. At sediment rate, we calculate what last column you see. And you see Series 1, 12, Series 2. Actually, these changes are due to slope change, due to sediment size changes. By that way, 3 series of data has been collected. You see, total. And then we did a reverse survey also through his help, because he is an engineer and that railway, बड़ा इंजीनियर है, प्रेस्टिजियस पोस्ट में है. तो हम लोग को 2 गाड़ी में हम लोग हमारे स्टूडेंट्स we had gone with his support actually to the river Koyna near to Jharkhand actually. We thought it is like a picnic. We enjoyed also. Research का भी एंजॉय करते थे, पिकनिक भी एंजॉय करते थे. Okay. Many times we just to go in the morning time, return back at the evening time. Okay. So by this way, we did some survey. You see some clips. Engineer Satish is here. You see, इतना बड़ा इंजीनियर ऐसा रिसर्च के लिए सब नहीं होता. देखो कितना बढ़ गया. हमारा विश्वजीत है एक्चुअली. Most many of you know my recent student also is here. Okay, वो सब एक्सपेरिमेंट कर रहे हैं रिवर का. So ज्यादा पानी नहीं था उस टाइम. But some shallow मैंने थोड़ा डिप भी था कुछ, that's why some arrangement has been made by that engineer, otherwise it was quite difficult for us to under the river survey in the near the bridge actually, and we measure some discharges directly because I see in the our country का जो data discharge data थोड़ा available नहीं होता है सर, properly you are not getting okay, data को ठीक से नहीं मिलता है, माने we are not able to get, that's why we did some direct measurement, and these are the changes and you see that the discharges, okay, and we actually took validate our model जितना भी था काम दुनिया में, that is called literature survey है, मॉडल को समराइज किया गया एंड आवर वर्क, उनका डाटा रिवर डाटा सबको माने वी कंपेयर एक्चुअली, okay, these are regarding parameters, okay, these are the different formulas. F means friction factor that we have model, F, U the mean velocity, U star you know shear velocity, that is tau by rho, tau is the bed shear stress by rho is the density to drop, R by D, R is hydraulic radius, D is the grain size, okay, so again phi the we'll discuss all these activities here, okay, you see first how actually very quickly I'll tell how he developed this friction factor model. First from the literature we summarize what are the factors, variables it is affecting the friction factor, this thing you see 1 2 U R mu like that way, 10 factors, वो 10 फैक्टर नॉन डायमेंशनल किया गया, फाइनली 5 फैक्टर हुआ, फंक्शन ऑफ 5, मैं एक्चुअली यहाँ पर थोड़ा कलर किया हूँ टू मेक यू डिस्टिंक्ट, एंड वी स्टडीड एक्चुअली थ्रू द डाटा ऑफ डिफरेंट अदर इन्वेस्टिगेटर्स आवर डाटा, स्टडी किया हाउ फ्रिक्शन फैक्टर इज बिहेविंग विथ रिलेटिव सबमर्जेंस हाइट, द R by D, aspect ratio, Reynolds number, Fouts number, all. उसके बाद finally we have developed this dimensionless dimension analysis made के, and finally this equation has been developed mathematically. Okay. Similarly for bed load transport, उधर में नहीं था, देखो your bed load का कुछ नहीं है, sediment का कुछ रोल नहीं है यहाँ पर, बट यहाँ पर D का आ गया, okay, sediment का भी R by D इधर, okay, finally this last equation we develop, that is important, होने के बाद again for two conditions, intense bed load condition and moderate के लिए phi is less than 0.4, phi is greater than 0.4, we have it has been developed, you see. So these are the two equations, and our so for phi is less than 0.4, this is the equation, phi is greater than 4. So two equations for friction factor you see, and actually after this dimension analysis he has gone for another computational software that is called MGGP, okay, multi-gene genetic programming, वो एक सॉफ्टवेयर पूरा डायरेक्टली दे देता है, डाटा होने से इक्वेशन डेवलप करता है, आजकल ड्यू टू कंप्यूटेशनल रिसोर्सेस एंड कंप्यूटर का ओके बेनिफिट से हम लोग माने मेनी टाइम्स वी आर टेकिंग द हेल्प एंड वी हैव डन दैट, एंड हियर एक्चुअली वी डिड आल्सो सेंसिटिव एनालिसिस ऑफ हाउ ऑल दिस पैरामीटर्स, कैसे पैरामीटर बिहेव करता है, माने हाउ मच इंपोर्टेंट दैट पैरामीटर्स, ऐसे आर्बिट्रल तो नहीं ले पाएंगे, we have seen actually by taking all the 5 parameters, R square is you see how much 0.9999, that means it is dependent on all 5 parameters, जब 4 3 किया वो बहुत कम हो गया R square. These are the multi-gene genetic program का वो क्रोमोसोम बहुत सारी है, okay, the things you can read actually, and these are the final equation that has been developed. Dr. Satish Kumar F. And these are the training and testing होता है. Finally, we compared with the other model जो तुम्हारा सॉफ्टवेयर में जो है, okay, that model के साथ compare किया गया. Finally, we see that हमारा मॉडल का R square कितना अच्छा है, दूसरा का पीछे रह गया. Sometimes I tell in Hindi, I think it is okay to all of you. Okay, so these are the results in terms of to tell about the strength of the models. You have to tell of the error analysis in terms of MRR, coefficient determination, our mean square error, root mean square error, like that. Many. Then our river का भी apply किया गया. Okay, finally we see that the latest model is the best one. Finally, final touch. I'll just within very quickly, within 5 minutes, I'll finish this. MGCB model for competent bed load transport. जो 5 दिखाया था, I'll tell now here. So I've already told regarding the morphology, bed load, suspended load, wash loads. Okay, and you see this is phi. Phi is the intensity of bed load rate. Okay, and Einstein actually 950 it has given model. That model everybody is taking care with that. And this theta is the shear's parameter actually. It is equal to tau. Tau is the shear stress, bed shear stress. Gamma S what? Specific weight of that sediment. Gamma, and D is the diameter of the sediment. And what is theta C? This is critical, means just the sediment will move some shear, at that shear equilibrium where that sediment will move. That is actually that happens at tau C, critical shear. Okay, and from the critical shear we get that critical shear number. Okay, theta C. So the theta C again, Pafitis 2001 has developed model. Generally, that has been taken widely taken care by the researchers and our engineers. Okay, and this field number with this theta, I told the variation has been studied. Finally, again applying this is our MGGP. It has been developed a model. This thing, phi and theta, sediment load and our silt parameter, unka साथ relations. These things actually recently we have developed, and that actually after developing that model, we also have compared with the existing equations, and finally our equation, you see 0.977 दूसरा का, and not only in our data, other का भी data को करना पड़ता है to publish in अच्छा journal ASC में करने से. Okay, to prove actually efficiency of the model, efficiency of the work, it is required. Finally, you see 0.977 with all the data existing in the literature. In terms of absolute error, root mean square error, actually every aspect we have proved that our developed models. So this is the conclusions, whatever I told. Okay, just summarizing this our conclusions. Okay, so some references has been taken care of this presentation. Very quickly, sorry, actually very quickly I told, though another actually double of this time should have been taken, but I know, but I am giving the PDF files to take it. You can share with me anytime for your help or further works anytime. Okay. Any queries? I want any discussion, queries, whatever. Pucho, please. Many things has been told. I told about river morphology, then our some research work, modeling work, experimental work, all the things. Please ask. I think questions. You are attempting to ask some questions. इतना है? Nobody? Okay, thank you then.
Thank you so much, sir. Thank you for your valuable words. We are going to start our second session within 2 minutes. Thank you.
Devastating floods have hit Libya, killing thousands as entire neighborhoods were swept out to sea. In the country's east, two
Hmm? এটা কেমন চলছে? এটা। আচ্ছা, এটা ফরওয়ার্ড, এটা ব্যাকওয়ার্ড। তাই তো? পয়েন্টারটা? একটা ব্যাটারি কম তো হলো। রেডি? ও হো হো হো। আচ্ছা 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 আচ্ছা, বুঝলাম। हाँ, ঠিক কাম করবে। এত সময় টাইম allotment করছো? 12টা 12:30 এলেন না? করবো না তো?
Good afternoon, everyone. Welcome to the second session. Today we have a guest. Sir is Engineer Jyotirmoy Behera. Give a huge round of applause for Engineer Jyotirmoy Behera. Superintendent Engineer, Additional Spillway Division, Bulla Samalpur. He has conducted physical model study of hydraulic structure, including scale selection, modeling construction, observation under different hydraulics loadings, data analysis, and reporting writing. He has completed model studies successfully for several major and medium dams and barrage in Odisha. Give a huge round of applause for Engineer Jyotirmoy Behera, sir. Sir, now the stage is yours. Thank you, sir.
So thanks to the Professor Khotta sir, so, no expert in that compound channel. I have been associated with you for a long time. Recently also I talked at month of December, I think last week of December. A similar actually talk I have delivered there. Now, I am going to discuss about uh, investment. Okay, okay. I have to put some down. Now, I- technology. Thank you. So, discuss a deeply aspect of the act which by 2020 and about the documentation program for with concrete and will the instruments about one study of them how implementing this and the final this picture this is the T dam located any your familiar you seen dam thing the dams dam Granada dam you know villages will go maintenance of the you can see there you are staying this is very maybe to report better to use the visit gallery fund is there so hard there the dam going to talk to you uh, that then we different okay this director the not this phase are very popular in report of 2000 news but काम collapse आया था the gang का time में road jam is clear at the bottom this made but intelligent the but due to the change to the field energy flood to the there are with the period we to share available okay the is for contact use of when the and then one day level clock the so that they can time in our time how for they will the electric so can for have that fast then consider that like this that no who want see the downstream of this dam. You can imagine the destruction of this city. So, in long to dam, we can protect downstream of the year Act and Parliament or 2001 implemented by all of it, and also the cases of that we are dam sufficient measure monitoring Odisha. The act provide for
this operations of the dam. It is a dam, master dam. So the Act set the document prepare because when the dam, so you are all one doing the records regarding the reasons or geological so uh, are heights of the dam. So then any change on phase also was including your for dam also to the document and maintenance repair or dam in all these records maintained. Since actual dam has and maintenance reading report review. So all are vital. Well, clause that shall have a favor of specified dam and of the dam the of the reading of this and safety so provision hydrometation. Okay, so dam whether that station the rain your the temperature and evaporation when also. We have also can see data file right process video dam ID how to process instrument and it is situated at very high code that is so you have to test also. Like the also that instrument to install comprehensive safety if you are dam to an in external we are active from from the new development other who are is there you can hire you can make for expert so that and that accordingly will and the general assessment dam operation inspection installation condition we add to the structure in the section so the organization the panel will submit the recommendation of the organization the organization that what they will follow. Condition for maintain should also help of the central organization like the health. This is this from the they all those presented held by but I'm safety of this organization that dams of they have the most dam failure you see the in case of body then to the next and the factor is the like the structure the next I can say malfunction of the gateway crash condition possible and also with some explosion dams or other factor identity. This is the cause of a dam accident overtopping into the plot. Then the pipe aquatic this is the valve failure like the dam was the close to another like cap because with the discharge no debate to delay to be another dam the water commanded why is it was 7 excuse now they have 55 lakh so 10 lakh how you have occasional which are in charge of the unplanned rights going to pillar another one so this 10 lakhs of water that one planning so the application left and also the study of the CW visited the Pune and then the water when that what of the Iraq it has bigger the impact on that there will impact more. So according to change the jet channel to a clear wall. Also the need the because every day health human we are going to check now like that. So every the thought instrument and different like a body mind and so just like and identify and that so that the catastrophe problem. But early one required for the of the regular state and you can alarm the and this is not in the problem is over the property then the people downstream have. Now, so it has so we can so we can even we can access those conditions. They are dam health actually in person. So when it comes on dam, it's a local the time for this because the chemical now the aggregate the so thing will change behavior. So distribution is necessary to dam and what to get the life of said effect of irrigation parameters the stress and also infection sequence comparing symptoms so design and the assessment like the stress certain values the limiting value but the is data the data you can also for design of health monitoring of also reserve and the down both one so that there you can see the is going on. And also have those one you can use for one of the and also explore types of materials. So those you can and autocast in a that is actually should have in the system this every support data and the record in the it is not really. So always automated systems are expensive. Also, sometimes engineers. No, not engineers should train in this field. Now, how also long. Every system is planning. When you do construction, we plan component where the foundation is where to put it. So everything I say. For plan component. We need to position present define water level the tell consume condition the operation and so in condition the dam when the dam loaded with the dam very much stress through the art then the art so sort of so that you check like dam has its own weight, like there is own soil also, but of the also wash down the soil. So start no movement. This is spatial variation. So temple you have to like temper your body. This temple, you know, the temple, so it is related to the temperature. And this sense and the influence you use for getting the alignment. So the alignment of the dam, you know, the alignment you know, from the you check the dam total or the you know the offline also the rotation are different. We have water stress, internal stress quality and also the after load when the food the back. So check that. So students discuss adopting the the parameter. Peter, what is it? And you so this is a moment through the joint or pressure usually pressure and the upward uplift pressure. When the uplift rises, so vertical down will be reduced. Stability and measure the because you know yeah. Also concrete dam water. So the stress direction. So maybe upstream 100 meter high on the joint dam blocks. So each movement for movement. The vertical you have to check. Meter is the meter. Level record at temperature at the variation or the field pressure monitor the on the base foundation. The pressure upward to call the pressure. Normal plumb line the it is from so in but also position the weather foundation. Students are the it is also the movement of that is a meter. This is the bottom compression based on the dam construct on the later of so there was a using the different device instrument and also any body crack and blocks and they said the robotic that is movement meters how of same slow vision movement to check and slow and you have to check the dots that provided parameters to monitor for segment depth. It has to be in the like stealing for so visual and the water flow and the also the discharge in the channel how to check pressure and the water and flow system visual of the erosion sides to check this the for the concrete gravity and you have to temperature all these parameters guidelines so actually are the typical you can put the the square set uh, up the geometry on the down downstream side uh, with the the foundation the found you can see the reservoir in the inside downstream that uh, so plan inside so meter here uh, meters are there and the cell up to inside and the foundation down foundation. Here also you can it's like downstream we have inside these are the we did the section gravity down see the you have to what temperature 5 field of the bottom one and this on the oxygen gallery. Right. That's to measure uh, number 6 that you can movement and so when that is the of the concrete gravity. Rock mass point movement summation of the forward point. So the this is the section asked what to foundation rock it will typical can put the instrument the actually patient. So we can issue instruments you required. It is mentioned on that. You know, measuring the you have to put instrument for section you have it actually all this. So imagine if the length is 200 then we use you have to meters and this is on the out in the bottom P1 P all these are the pressure. S S and for that if before if you see actually this team the temperature you can outline the gallery. So all this is it is a physical measurement what two types of available is open another is actually now the electric press vibrating okay this is the wall work instrument we are going down foundation like this this is this because the materials are small it is some pressure so the trip is electric size actually the by technology actually I can't whole movement the electric frequency that it out the digital out. This is a type of for the and look at the roads. This is the same as the surface of the water inside. I to at the concrete. So that express you have to for down system. So if you could have we will see the always water is right? Measuring the rate of water passed rate. It is actually here the flow from the crack is area. So the water and so drain already is now it is coming from the block result and measure sequence. Can also the water aridity color is changed. When your depth when that air is inside that, so the soil coming concrete coming inside that, and this seepage both aridity level or tailwater level of the one when your dam the issue and generally the flow measurement inside are no inside is less than for so to angular node if you go for the trapezoidal for here that you can see trapezoid. This is and that is the uh, uh, small can see for fire and velocity. So just rain to use this and calculate. That is the strength the dam is with what so the slurs are so time to what the assume as part of the stress part of that parameter totals the dam is a bottom component value of those data is design data for improvements. The stress design it is different to the stress creep change the growth of the grid. And for the is directly detect stress. So how you first you have to measure the string that is ratio velocity model in the creep what you will get and then apply the formula uh, for so very well it is with the it is load or corrosion better with the alkaline it is also country administrator the point to measure. So the is also get that in the so that the strain can strain which is like the remote digital read of a compressor strain. You will get all strain and put plus that is 0 one plate the right hand. So measure in direction strain. Inclination of the yield may result from loading of structure. Data for the provide of the for aligned corrective act. This is the instrument. Uh, consider the chair causes the tilt of the inside foot of the another this type loads it mind determine a rock or fuckers found it the ants during the so what is a total to that table. So use this instrument check the total. It is also flexible for the data like 12 devices. This is uh, how we fixing and displaying of both and the sitting and the load plate. So capacity from 200 to 2 kilo. This is and the DU and requirement what you are looking repairable positive to or overall extension is another instrument help resist standard formation of surrounding and what extensions express time in several of the of the rods 4 and 5 that and that this is that will send the readings. This sections of new instrument. The specification can to go for the another track. I will the vertical change vision of the dam, the structure feature, elements of span of structures. What is change of the sub and this is the which the plastic system that they are using the scale plastic area directly the wind directly that is the gas the water by the civil uh, can also you can tell the water this and they are available components opaque unopened is the result. It, uh, and the cross side. So uh, uh, and then on it at there at reading. See, available available meters to compound device plastic as opaque in it and has just the red opposite desert the location to the great and then use the process in the object as the display and directly on your scale you can direct reading on the display. This is another instructor. This is also the where the see another crack in the market. It can and when that is that will actually when actually what is actually that it will wire inside that case. So automatic server will quit crack and you just drill at instrument of for the crack in Haryana manufacturing uh, around 5 to probe their two sensor series to uh, probe to that to scale is on the right side. So you have what you have to move, you have that of crack both width and depth of crack. This instrument this instrument only 60 centimeters more than it can the or axis beam or side so this is our lab this, that is this right hand to the lab camera can that cameras this are available that is micro tools available so we would measure of that and this is the operation to the scene of use this one during cooking. You can make the width and you can map crack, two cracks, check every 5 years you have check the cracks are you have to check for the these cracks. Another is it when the more than are the meter during the acceleration in horizontal to put elements yeah, the A dash is about have to put one in the right assuming with and also you have the left side one in board and one in another which is not here your location monitor and this is a very complex instrument can three levels direction and this is the response of the sensor technology another vital water measure the reservoir until one. So we are putting everybody can sharing this and this sense of this is not that personal to us and here the level is more check has been somewhere water location. So during this level we have a now the art survey uh, temperature vital parameter. These are actually gravity down across the sun of the dam. Outside the out tells the uh, available like temperature register uh, thermal static oh, you put away data from the services so there multiple available can instrument that are single single also available also up to can also to learn where this aspect to storage dam does this actually action. There has to think and in this data. The you know the level will be four extent of simultaneous. Okay, accommodated students. This is a channel where can the corner the instrument single channel availability anti. Suppose your remote like mobile use this and it will also in your data alert has the system it can store the amount of put and staying out from you can also see from so also all the hybrid engaged are connect to the territory measure and covered and very people know the mobile GPS is powerful because it's data faster technology. So data transfer network to how you can water so you can check how so you can use this that laptop and you can transfer needed for and also through and Mozilla Firefox dashboard. Very user that at all these meter your meter or the all this through your data and the data connected and you can cloud and then what user download this and see the location data you kind of get same one panel. So this help everyone to fix the dot and change the serial number also change the remote office and config is mobile on app you can in Android also you can and it gives program for it 10 to some percent capital so you have the retrieval and you can see upload all this as a single data multiple use the list results instrument container solar panel the this is second model then all these scam has the logs, concrete development, heighter, gravity dam, so 1,000 parts of it. Had so dam. Now they are invited data source critical dam and install a foundation page of operation will pressure cells and temperature which is the most of it. This code and documents inside either well and notation of anyone is your instrument. So actually that this done by the CW then the critical and validation movement but different temperature constants. The one is the model. This is the one. Question also the session always very information vacancy. And these are the available lesson of institutes are available and available to look at them. So all the reason for the front to the instrument is very tool in evaluation one instrument is mostly evaluated to be right of a data or problem is where is the movement correlated upload record that help in evaluate around that free from edges. The recommend renown by the instrument it always not for no or if actually it is a very young application. See, have an instrument measuring the pressure because sometimes the it is not uh, what illusion. But now if planning to new era here old the instrument guide bank expo. A good because it is a very because foundation is produced concrete, so they can for like other temperature they can do it. Just so actually we engineers say about this thing. So we start so this the world currently so nowhere see any nation. Within now Turkey has concept and they have created a central implementation. So look here, Pune, they said, what do you get now for fund for that test? For guidance, so next year so we'll have a new. But my idea is we have we have another growth. So after we get all this. So
Very. In a short, going to technical stages, short time. Uh,
we have to realize that times these instruments are useful. The water is can for things. And now says such particular safety say that road I am for my chief professor spot that these so people need to join center it will be good. Similarly, as the told that and as additional way this thing uh, uh, so that the arrangement we do when we should be good way and we are in the high all in that the atmosphere perhaps you should be thinking that was a need is it only at the good jam adequate cater be catered the that is the asking to the person who is the now to session good bad hell I am my to take is about personal board and but how getting and into play and whatever apply all this in a I it's like it's showing I selling Abu uh, please. We have just every uh, uh, here we selling in the as the starting more in that good for
Hello. Hello.
Good afternoon to one. Am I audible to you? Am I so far there are for provides a good present in the actually honestly I knowledge about CFD. I will learn up sir what taught me just say some CFD. I recently they had also conducting the workshop on made memorable sir sir. So concern sir put totally initial we did the close we don't have channel actually we through the open we are very that how to start the open if you internet you out that close research paper you'll find a lot if you go it will come my running what I are both open close it will be open Sarjati and NIT has taught very value training on the rail and we lots of are if you are get you can direct that anytime Mark will call me very huge opportunity lots sir sir today I want to do about CFD GNT means computational fluid or computer dynamics right so this computational fluid is general nothing but it of the fluid that is of the motion of the conversion of diabatic so all about diabatic computational fluid deal with and why choose the fluid dynamics because if generally is flowing in a particular requirement why we so basic first is low cost we can and visual beside the pipe the behavior of we can analyze and also it is relatively how to cost example working in a oil or suppose in assume that fluid at inlet let us assume just and it has the 3 meter per of the fluid the thing at the end velocity so how to design so in the traditional we try and trial method we follow the thoughts but now what that can solve that by or virtual mode it just a lot and engineering can also design make that thing the fluid is 4 factor 2 to three was press turbulence, the things that if it at this much velocity but coming from the y, so by CFD we can if my point it relative or to do something for the model prototype we have to prototype is failed. House cost is it's a lot of cost, but if I'm we are getting the input, what then that's we by knowing then we will after that's matching on. So it is CFD is and factor is a lot of can do a lot by use hardware. We can behave it when the interacting with the, that is the thing is urban nowadays or flash most important we are when in any case having not affect the we can see erase the maximum at place the what content by simulation. CF we but it is a project on the event transport. We can with CFD is easy to do the by the thing in our we did already on the open we did a yeah. So this is have taken a and it is 100-meter long, 100 center meter, and it the if you go to analysis and the frictional loss and the make what I will that on the turbo sir in the 2000 I think Anu Chandra Pamina Pro on 7 R&D when we paper and sir that a lot of 23 we are in 2000 did that sir. Next slide. Note 2 just I have what are the followed the post I'm using for your in the 4 method boundary for this and fishing and it after the condition see you will get hurt but tricky is you did that we already tell that so we have first or any you can structure with the structure will not happen. So about the we place a white if say this side is of what that divide into the maze, number of generated amount of activity we will get. Place a 5. If I was wrong, what will be wrong? Also put also debate pairs of them. Only in that is 5 in ANSYS paper of ways for your record. So also we use 0. For the value. Missing value nodes come about the next step. Then come to the solve a solution. This is the urban next slide. The next slide. This is the software. This is the CFX flow. You can use both. Basically, CFX do this basic. CFD is being there. They are also using heat transfer and flow fluid. That there are restrictions missing. Set the geometry. You have to. Then we did the mesh. Okay. Then this is the we have generated and section. We have the pipe we generated. Computer will know this one is the that one is the main thing type of fluid said that will know the part you solid. It is the and the whole. We have to also define that out. Then and we will go for that number of node 1000 node value, but in ANSYS student up to 5 value. So 0.01 element 0.0 element after penetrate we press it. Now we do that we provide boundary condition in open. There are a lot we have to sub or sort from contraction or sort that thing, but this is the condition initialization activity path and the path and run close the fluid. Next step, this is the view. After this is the view. This is path from this side to this is the in the next. We back to that. So define the see the so give the in the y direction gravity that the my we give then post keeps people of the static in the at the in the color we generally if you are this index of value this in one index state from this blue that blue lesser or how to calculate we have to assume in this one we have to match and interpolation or what for perfect value at the so that this is the initial 30 pressure and pipe was increasing, the also decrease. Next slide. Same line with the fluid pipe. See that some of the fluid, some of the I just say means the or the value the pressure that is in this case is the velocity. The video. The condition. Three basic. Then this is the of the post. What is here? We will see. Okay, their videos. It's okay. If we all or in a flow, where is the value? Center line. I know that in the FB, the velocity of the pipe was the max. So this is balls. Are the those solid part of the solid who reacted using velocity because friction, because of friction, and those which were solid their velocity. This is the question, and we are just did that. Is all, and also we initiated the 2 meter admitted to the interline and also done in the lab that differs a little bit, not get the validated things. Times. Sir, it depending upon your system, how much you will be strong, will get the iteration thing that simulation is the things. Yeah, I say messing up. So yes, maze is easy. The thing is, it would we have by the number of items or different value. Like number of yes. Yes, sir. If we look actually, sir, major project was to their project. Yes, sir. Yes, sir. Yes, sir. Sir, but this lit class company for that. Yes, sir. Yes, sir. What is sir, the boundary? You, we must have sense is of the flooding, sir. By but that until not that correction will be wrong. Present. So, correction also required. And sir, sir, I am the friend of him, sir. Sir, just express, sir. Sir, he to me, sir. Sir, anything, sir, sir. Sir, thank you so much.
To us, it has visited here. Are not working. Came to mind. They are working. Jyoti sir, both are working. Kanyakumari, there is uh, also what is Spillway profile. Thought that in the why it's applicated. Yes, so watching and he came. I need. But I have to. And I told that Babu and all visit Kerala and in Prabhu and at least a single two and who is them. So I think all this. Thank you. It is the hot room is over. So I am for
Sir, to request, sir, some students we want thanks to. I will request Professor Karasar to. Thank you, sir, giving us your valuable word. For joining. Please, guys. And also, Aru, it was a huge round of thank you. Today we will more for session. I will visit tomorrow. The part those are in please. So for the session, thank you everyone.